In this example, we're going to write an equivalent expression by rationalizing our denominator. First, let's see what we can simplify under the radical. We can simplify the t's by subtracting our exponents. Next, I'm going to break this up and put a radical over the numerator and a radical over the denominator. In our numerator, notice that t squared is a perfect square. This means I can take the square root of it and put it outside the radical. Now let's look at our denominator of the square root of 32. We're going to rewrite the square root of 32 as any perfect square, the largest perfect square that we know of, that will divide 32 times whatever else it needs. 32 can be rewritten as 2 times 16. Since 16 is a perfect square, we can take the square root of it. The square root of 16 is 4, so that goes on the outside of the radical. The square root of 2 stays inside. Now we want to rationalize our denominator. In order to rationalize our denominator, we multiply the top and the bottom by the square root of 2. Whatever it is that's under the square root sign, that's what you're going to multiply the top and bottom by. Now we have t times the square root of 7 times 2 of 14. And on the bottom we have 4. The square root of 2 times the square root of 2 is just 2. Remember that whenever we take the square root of anything, say x, times the square root of that same thing, we're just left with the number that's under the radical. So the square root of 2 times the square root of 2 is just 2. Lastly, we can take 4 times 2 and multiply these two together. At this point, we are done. We can't simplify any further. Some of you may be tempted to simplify the 14 and 8 because they both can be divided by 2. However, we cannot do this because one is under the radical and one is outside of the radical. They would both have to be either outside the radical or both inside the radical in order to do that. So we are completely simplified.